Hello and welcome to our micro-lecture on generalities of life cycle assessment, part of our development module focusing on technical expertise and sustainability. We're excited to share insights and knowledge that will empower you to make informed decisions in procurement processes. Let's begin. Life cycle assessment, LCA and cradle to grave are oft quoted terms. But how much is known about the methods behind these words? This micro-lecture lays out the basics behind LCA studies and explains what it is, who would use it, and how to perform such a study. The main objectives are to understand the concept of life cycle assessment and its role in sustainable development, to identify opportunities to use LCA to assess the environmental performance of products, and to gain and apply basic technical knowledge of LCA tool and software to track sustainability metrics. Life cycle assessment is a method to assess the full environmental impacts of a system. It is a quantitative tool which aims to avoid emotive attitudes such as fossil fuels are bad or organic is better. Instead, it is a process of evaluating the effects that a system has on the environment, including extraction, processing, manufacture, transport, distribution, use, reuse, maintenance, recycling, and final disposal. As such, an LCA is said to include the cradle-to-grave impacts of the system in question, but may also be defined as cradle-to-gate, or gate-to-gate. Thus, the use, recycling, and disposal is included, not only the inputs and outputs of the production of a product. The results of an LCA can be used for many purposes, for example to develop a baseline of environmental and human health consequences associated with a given product, process, or activity. Life cycle assessment involves the systematic identification and quantification of natural resource usage and environmental releases throughout all stages of a product's life cycle. It evaluates the potential environmental impacts associated with these material uses and emissions, providing a comprehensive view of their ecological footprint. Furthermore, it helps to identify opportunities to reduce environmental burdens and implement system-wide improvements, making it a crucial tool for advancing sustainable practices. Depending on the user, LCA studies may have different practical applications. Industry may use LCA to understand the full life cycle of their products, processes or services, or to understand their contribution to the total impact of their business in the full life cycle. Government may be interested in things such as eco-labelling, deposit refund schemes, subsidies, taxation, or general policy decision-making. NGOs may use LCA to supply consumers with information, support public decisions, or influence enterprises and governments. For all three instances, the buying power of consumers will influence market trends, and environmentally friendlier products may be preferred. Where consumers lack trustworthy and comparable environmental information, LCAs can provide this information. An internationally accepted framework for LCA methodology is defined in ISO standards 14040 and 14044. These standards define the generic steps which must be taken when conducting an LCA. 4 different phases can be distinguished. The goal and scope of the LCA study are clearly defined in relation to the intended application. The inventory analysis involves the actual collection of data and the calculation procedures. The relevant inputs and outputs of the analyzed product system are quantified and modeled. The impact assessment translates the results of the inventory analysis into environmental impacts, for example global warming, ozone depletion, or acidification. The aim of this phase is to evaluate the significance of potential environmental impacts. In the interpretation phase, conclusions and recommendations for decision-makers are drawn from the inventory analysis and the impact assessment. The first step, goal and scope definition, sets the foundation by outlining the LCA's purpose and the boundaries of the study. This ensures that your LCA is performed consistently. The goal and scope defines what it is that is to be investigated. Are the goals of the study to perform a strength and weakness analysis, product comparison, product improvement, or eco-labeling? Further, a functional unit is defined. This is the product, process, or service which is to be investigated and is related to the type of study. For example, the production of 1 ton of paper, driving 1 kilometre in a small passenger car, and so on. The functional unit may depend on the level of detail required in the study. When looking at an entire life cycle of a large process, multiple products may result. If the primary product of interest and the functional unit is unclear, allocation or division of multiple products may be needed. The second step of an LCA, the inventory analysis, can be seen in engineering terms as a mass and energy balance. Inputs and outputs, including the economic values, like services and goods, as well as environmental values, like resources and emissions, are needed. This requires that the full flow sheet, including all processes required in manufacture, use and final disposal, are known. Environmental input means something you take out of the environment to put into the product's life cycle, for example, the use of raw materials and energy. Environmental outputs means something your product's life cycle puts out into the environment, for example, the emission of pollutants and waste streams. Together, this gives you the complete picture of the life cycle inventory, LCI. The LCI is all about collecting relevant data and modelling this data via inputs and outputs in a correct manner. The entire life cycle implies that the flowsheet starts with raw materials and ends with final use or disposal, and includes all emissions, like air, water and solid, along the chain. Data can be collected from literature, LCA databases, industry data, government records, or physical measurement. This is often the most difficult and time-consuming step. Once the processes are defined, the system boundaries, which are not always obvious, can be more carefully defined. Subtle changes to the boundary can have a big influence on final LCA scores. Data that is directly calculated or measured for the specific study are known as foreground processes, while data collected from secondary sources, databases, are known as background processes. LCI data are classified as primary data, representative secondary data, or proxy data. Primary data, which include LCI data collected from the manufacturing plant, where product-specific processes are carried out. LCI data collected from other parts of the life cycle traced to the product under study. For example, site-specific data on the production of materials provided by contracted suppliers. LCI data from secondary data sources like databases or literature on transportation or energy where, like electricity, fuels, and heat, that are combined with collected activity data on energy, like quantity and type of electricity mix, fuels, or heat, and transportation, like means of transportations, fuels, distances, or load factors of contracted transportation providers. Secondary data from databases or literature are divided into representative secondary data, LCI data that fulfill the data quality requirements in Section A.5.3 of the ISO standard, .proxy data, LCI data that do not fulfill all the data quality requirements of representative secondary data in Section A.5.3 of the ISO standard. Once the necessary input and output data is collected, the next step is to model the product system using an LCA software tool like OpenLCA or Helix. This involves creating a digital representation of your product's life cycle, incorporating all the processes and interactions identified in the initial part of the LCI phase. For companies that can't or haven't yet measured themselves, the inputs and outputs are linked to environmental impact data in the LCA software tool. The model must be accurate and consistent. All of the units and methods in your data must match with those defined in the goal and scope phase of your LCA study. This might involve converting scientific notations to standard numbers using particular units of measurement or scaling data to fit your functional unit. The final step in the inventory analysis is to construct an inventory table. This involves converting all the material and energy balance numbers across the flowsheet into values relative to the functional unit. These numbers are almost all mass values. Like energy numbers would have become mass values, since, for example, a kilowatt of energy would require a certain mass of coal or other fuel. Some things may not be picked up in numbers alone, for example, soil erosion, noise, rainfall, evaporation, or the exact site location. In the Life Cycle Impact Assessment, LCIA, you evaluate the potential environmental impacts derived from the inventory analysis. This allows you to understand sustainability challenges better and make better business decisions. You classify the environmental impacts of all processes collected and modelled in the LCI and translate them into environmental themes, such as global warming or human health. The impact assessment process begins with selecting and defining relevant environmental impact categories. Next, classification involves assigning inventory data to these categories. For instance, linking CO2 emissions to global warming. Characterization then quantifies the impact within each category using scientific conversion factors, such as assessing the warming potential of CO2 and methane. Normalization enables comparison of different impacts by expressing them in a common context, while grouping organizes indicators based on criteria like geographic scale. Weighting highlights the most significant impacts, and finally, evaluation and reporting help assess the reliability and significance of the results. The International Organization of Standardization, ISO, developed a standard for conducting an impact assessment entitled ISO 14042, Life Cycle Impact Assessment, ISO 1998, which states that the first three steps, impact category selection, classification, and characterization, are mandatory steps for an LCIA. Except for data evaluation, the other steps are optional depending on the goal and scope of the study. There are two mainstream ways to derive characterization factors, for example at midpoint level and at endpoint level. ReCyPy method calculates 17 midpoint indicators and 3 endpoint indicators. Midpoint indicators focus on single environmental problems, for example climate change or acidification. Endpoint indicators show the environmental impact on 3 higher aggregation levels, being 1. Effect on human health, 2. Biodiversity, and 3. Resource scarcity. Converting midpoints to endpoints simplifies the interpretation of the LCIA results. However, with each aggregation step, uncertainty in the results increases. The figure shown provides an overview of the structure of ReCyPy method. The final phase of the LCA, when the study's results are interpreted alongside its original goals and scope, may be the most important of all when it comes to the ISO standards for LCA dictate that this interpretation should identify significant issues based on the LCI and LCIA phase, evaluate the study itself, how complete it is, if it's done sensitively and consistently, and account for uncertainty, and provide conclusions, limitations, and recommendations. The fundamental purpose of this final phase is to identify priorities considering an LCA's stated goals. In this module, we learned the concept of life cycle assessment and its role in sustainable development, and how to use it as a tool to assess the environmental performances of products. Some of the main takeaways from the micro-lecture are that LCA evaluates the environmental impacts associated with every stage of a product or service's life cycle. It supports the identification of ways to minimize resource consumption and emissions. By providing comprehensive insights, it facilitates informed decision-making for developing more sustainable products. We encourage you to connect and discuss LCA with your peers on the course forum.